AP-style free response problems. The following questions refer to this electrochemical cell. Write a balanced net ionic equation for the spontaneous reaction that takes place in the cell. Given the following values, calculate the standard cell potential, E0 for the reaction in part A, those values. On the diagram, label the anode and the cathode. Determine the concentration of silver nitrate and the concentration of zinc nitrate that are needed to generate E0. How will the cell potential be affected if potassium iodide is added to the silver half cell? Justify your answer. Write a balanced net ionic equation. We will have to rewrite the equations, reversing the direction of the zinc equation since it has the lowest SRP and will be the anode. Then balance them for matter, including electrons. Now the first one has 2 electrons, this one only has 1, so we'll have to double the silver reaction. Then add them together. So here's zinc, just as it's shown above. Here's the reversed and doubled silver reaction. Add them together, the electrons go out now, and here we go. That's our answer. Calculate the standard cell potential E0. As we found on the previous slide, zinc is the anode. So what we do is we subtract the anode potential from the cathode potential to get the cell potential. So the cathode has 0.80 volts minus the minus 0.76 volts for zinc, and we get 1.56 volts. Label the anode and the cathode. Well, silver is the cathode, zinc is the anode. Determine the concentration of silver nitrate and zinc nitrate. The concentrations must be 1 molar. Otherwise, the potential would be different than the difference of the SRPs. They could be determined, however, by the Nernst equation. How will the cell potential be affected if potassium iodide is added to the silver half cell? Justify your answer. A precipitate will form as the iodide ions react with the silver ions in the solution in the cathode compartment. That means the concentration of silver ions will be decreased. A decrease in the concentration of silver, down here, here's our Nernst equation, will cause the Ln term, right, this whole term here, to increase. That will lower the cell potential, okay, because of this negative sign right here. Lower the cell potential.